As mentioned, my name is Aran Lessard. I'm with the Florida's Turnpike Enterprise, which is also known as FDOT District 8 within the department here in Florida. I'm happy to be here with you this morning to share our experiences with ongoing efforts related to the development of bridge preservation-related performance measures. After a brief introduction, we're going to talk a little bit about how we're currently set up in usage of various performance-based mechanisms that provide work on our bridges. I'm going to talk a little bit about preservation strategy we'd like to promote further in the future, as well as some performance objectives that may be tied to that strategy. First, I think here are a few headlines that are all too familiar with us these days. 174 million daily crossings on over 54,000 structurally deficient bridges in the United States today. Wow, that's a lot of people. ASCE indicates America's infrastructure scores a D+. Well, that's not too reassuring. So right around just under 10% of all bridges in the nation are currently considered structurally deficient today. But here's the good news, though. For any of you guys who have been tracking that number, we've been steadily trending downward for as long as we've been reporting on that metric, percent structurally deficient bridges. So we must be doing something right. I think a lot of that has to go with the amount of research and focus that we put in this area as an industry. How's the saying go? If you measure it, you will achieve it. Something like that. That's exactly what we want to talk about today. Developing performance measures to drive bridge preservation type strategies and activities. So originally when we began looking at this type of information, I guess I would say our focus was more related to our various performance-based contracting mechanisms. For me that may not be aware, Florida has been steadily transitioning more and more to greater use of performance-based contracting to operate and maintain our transportation infrastructure. We have shorter term, what we call asset maintenance type contracts, which where the contractor will assume the risk of all general maintenance and repair type activity. And we also have longer term concessionaire type contracts where the contractor will assume a bit more risk, usually in the form of either rehabilitation or replacement should the need arise within the term of that contract. So right around 70% of all state-owned bridges are currently included within the scopes of these contracts, some way, shape, or form. And that's almost 5,000 bridges, and that includes some of our biggest and most prominent bridge structures. So our current processes for driving the work on bridges is pretty heavily dependent upon our inspection activity to identify work needs and drive our work programs. So we think that there's opportunity for greater consideration for doing those types of things that pay long-term dividends for us over time. So a little bit on the approach. So about a year ago, we established a small technical working group we call the Bridge Performance Group. The main focus of this group is to review our various performance-based mechanisms that provide work on our bridges and look for opportunities for improvement. So it's an 8-member group, and given the contribution that private industry plays in caring for our bridges here in Florida, we thought it was pretty important to include their contribution, their representation within this group. So we have 3 serving members from individual private industry firms who participate in our performance-based programs. We have 2 serving members from our central office, as well as 3 serving members from some of the districts. So I think one of the first things that we found is when we began working as a group, we found ourselves asking the question, when we talk about performance, how do we define either good performance or bad performance as it relates to caring for our bridges? I mean, it's a good question. And I think sometimes we know that condition can be a pretty good indicator of performance, at least past performance. If our bridge is in good condition, we've probably been doing a pretty good job. If it's not in such great condition, maybe we haven't been doing so well. So what you see here is kind of a generic asset deterioration curve for any long-term asset, like a bridge, where condition is reflected on the vertical axis and time on the horizontal axis. And what we know is usually a pretty good thing is if we continually focus on making sure that we do those right things at the right time. I know that sounds like a cliche. For bridges, what we're talking about is making sure that we keep up with our general maintenance obligations, making sure that our repair program is responsive to our repair needs over time, that we're doing our repairs in a timely manner. And yes, there'll be the occasional need for rehabilitation and or component replacement projects. Let's just call these preservation actions in general. We know if we do these things consistently and effectively over the long term, we stand a pretty good chance of remaining in an overall state of good repair over time. And more often than not, we know it's those minor, low-cost actions that tend to pay the greatest return on investment over the long term for us. So that's really what's shown by the green sawtooth curve on the top. whereas the alternative, non-preservation path, if you would, shown in red, really gives you a sense of what happens if you don't do those things. Sooner or later, you'll probably have to make a substantial investment using the form of either major rehab or even worse, replacement if things get too bad. So as far as bridge structures, we know that there are certain types of elements and components on bridges that I guess I would say they serve more of a protective role in nature. Things like our expansion joint systems and our seals help keep our water and debris up on top of the deck. Things like our coating systems help protect our structural steel from corrosion and degradation. Wearing surface helps protect our bridge deck from traffic-related abrasion. Even the bridge deck itself can play a protective role in nature at times. I think sometimes we look at the bridge deck, it's kind of the roof of our house. Sometimes if our roof starts to leak, we know it typically contributes to bigger problems down below for us. Are there others? Absolutely. This is just a short list of some commonly recognized protective systems for bridge structures. So as far as overall strategy, we know that it's usually a pretty good idea to continually ensure the functionality of those systems that are more protective in nature. If we do this consistently and effectively over the long term, we stand a pretty good chance of preserving our core structural elements throughout the entire life cycle of the bridge. Sounds like a plan. So how do we drive performance as it relates to these goals? Well, we know the bridge inspection process is a pretty valuable tool in our toolbox. You know, our inspectors are out there generally once every 2 years, reporting on condition and function of every element and component on the bridge. We call this our element level inspection criteria. So we assign a condition rating on a scale of 1 to 4, 1 being the best, 4 being the worst, on every unit of every element on the bridge. So there's lots of detailed data that's generated through this process. So we think that there's opportunity to leverage the value of that data to inform and report on the condition and function of those systems that are more protective in nature, to make sure that we're doing the right things at the right time. So as far as performance criteria, we believe there's opportunity for what we're calling condition-based, outcome-driven performance measures that will serve to provide value in the overall life of the bridge. Remember those 3 terms, condition-based, outcome-driven, and provide value. I'm going to talk a little bit about each one in detail in the next few slides. We believe, if appropriately established, will serve to incentivize performance and promote innovation as a whole in our processes. So what types of things are we talking about? Well, we believe there's value in minimizing the leakage in our deck joint systems, because when our deck joints begin to leak, we can see elevated rates of deterioration in portions of the bridge in the immediate vicinity of those leaky joints, especially for steel superstructures and bearing components. We believe there's value in maximizing the effectiveness of our coating systems. For any of us who have watched our coating systems degrade, we know it's never uniform. Typically, we get early onset and a breakdown using those hard-to-coat areas first, whether it's on the nuts and bolts, the edges of plates, those areas that collect debris, retain moisture. We believe there's value in ensuring a uniform level of protection for all of our steel components out there. So when I mention condition-based, generally we're talking about leveraging the reporting that occurs through our bridge inspection process to inform on condition and function of those systems that are more protective in nature. For any of us who have recently observed our changes in our inspection standards, we know that our information has become a little bit more detailed with the advent of new standards. So no longer are we only reporting on quantities within the individual condition states 1 through 4, but we're also reporting on quantities of what we call commonly occurring defects, which can vary based on material type or even type of system, whether it's an expansion joint system or a bearing system, things of that nature. So as we progress through the process on this end, we realize that it could get a little tricky to ensure a certain level of value in our process. The devil's in the details. So what I did is I put together a short example to illustrate some of the things that we've learned as we've kind of researched on our end. So as we look to ensure a certain level of functionality in a particular type of component, naturally we look to ensure that we have at least a certain amount of good quantity for that particular component. Taking a look at the reinforced concrete bridge deck as an example. So if we were to say we'd like to see at least 95% of our deck area in condition state 1, sounds like an admirable goal. First, let me say if you see any percentages in red in this presentation, it's only because they're placeholders at this point in time. We're still evaluating to see where those optimum thresholds may lie for us. So as we look down below, we see that the table includes the condition evaluation criteria, with which our inspectors report on condition and the occurrence of those commonly occurring defects. And we realize that condition state 1, although pretty good state of affairs, doesn't offer a lot of wiggle room. And we know it's usually a good idea to have access to viable repair alternatives to attain our stated goals once those deficiencies do pop up over time. Cracking is an example of one that does. So if we look at, I know it's tough to read here, but apologize for that, but if you look at the definition of condition state 1 for cracking, we see it allows for insignificant cracks or cracks that have been sealed. See, that's our traditional repair response. In a progression of deterioration, as a crack occurs for that localized portion of the deck, we'd move to one of the higher condition states, either 2 or 3, depending upon the nature and scale of the cracking. We'd move forward with an appropriate repair response, whether it's epoxy injection, surface applied sealant, and which should, if we're successful, should bring us back to our stated goal of condition state 1. Whereas if we look up above, a new for the delamination spalling, different type of commonly occurring defect, we know that our traditional repair response for this type of deficiency is to provide for a localized reconstruction of the deck in the vicinity of that crack or that delamination or spalling. We see that patched area that is sound is included in condition state 2, so we could provide that action, but it wouldn't necessarily return us to our stated goal of condition state 1. This is what we're talking about. Same bridge, same location. Photo on the left is before the repair. We've got the occurrence of spalling, some exposed reinforcement. Photo on the right, after the repair, you can see that we move forward. We've applied a suitable repair product. More often than not, we're using very durable products these days, high quality products. And we like to use the term installed in strict accordance with the manufacturer's recommendations. So those that have rigorously product tested their products to ensure durability over time. So we want to make sure that we apply the appropriate surface prep, saw cutting, any adhesive bonding agents, whatever the manufacturer recommends. When we do it, we understand that we get significant durability in that repair effort over time. I think sometimes when we use the word patch, it's kind of a misnomer. Kind of lends the belief that it's kind of a Band-Aid that requires continual application over time. And it's not necessarily the case in this instance. That's really the outcome-driven portion of what we're talking about. We'd like our process to acknowledge the benefits of repair activity where appropriate in restoring functionality. Because in the absence of acknowledgement, it becomes a bit more difficult to encourage or even incentivize doing those types of repairs that could pay long-term dividends for us. In this instance, that moves us in the direction of expanding our definition of what we consider good to now also include condition state 2. What we realize is that now opens up the door for a few other defect scenarios that we may or may not be comfortable with. If we look down below at cracking, we see that condition state 2 allows for unsealed cracks of moderate width. I don't know, on the deck top, area that's exposed to continual wet-dry cycles. In the north, we're putting chlorides on our decks. Not in Florida, but northern states. We could be exposing our reinforcement to undue corrosion activity. Certainly, exposed rebar, defect 1090, condition state 2 allows for present without measurable section loss. Really, this is what we're talking about. Sometimes, for any of us who have ever watched our rates of deterioration for reinforced concrete components, we know that there are certain types of scenarios that when they present themselves provide for, let's just say, a tipping point in our overall rate of deterioration. Things really begin to pick up steam. Exposed reinforcement is a good example of that. Spalling occurs. If reinforcement's exposed, corrosion's initiated. Corrosion is an expansive process, exerting internal stresses within the concrete, contributing to further spalling, further exposure reinforcement, further corrosion initiation. So it just becomes a cycle at that point. So this is a good example of a typical defect scenario that we'd like to take steps to avoid, if at all possible, because it tends to promote higher rates of deterioration in our base components. And that's really the value aspect of what we're talking about. We want to set ourselves up for success, make sure that we have the greatest opportunity to preserve our bridge structures, to realize our full asset value potential, which has really brought us to where we are today when we consider our performance measure format. So we're currently considering a format that includes two main parts. So the first part is going to include a condition state criteria, where we look to ensure that we have at least a certain amount of good quantity in support of overall functionality. Second part is going to include defect criteria, where we look to take steps to avoid those undesirable defect scenarios that can promote higher rates of deterioration in our base components. So here's that same performance measure in blue restated with the two parts. For the reinforced concrete bridge deck, we're saying we'd like to see at least 95% of our deck area in either condition states 1 or 2, with less than 1% of area, including either exposed rebar, defect 1090, and significant cracking, defect 1130. So as we look down below into that same table, condition evaluation criteria, we see that everything in green is within the realm of our stated performance objective, acknowledging the benefits of repair activity where appropriate and restoring function, and avoiding those undesirable defect scenarios that can contribute to higher rates of deterioration as much as possible. So given the same two-part format, we're currently test driving draft performance measures related to the various types of deck systems that we have. Reinforced concrete, pre-stressed concrete, steel, timber decks, and that other category, kind of a catch-all. Again, using that same two-part format, and the really only place that they vary is in that defect criteria, that second part, because our commonly occurring defects will vary based on material type. We're also looking at 2 on our expansion joint systems and 1 on our steel coatings, again using that same two-part format. So the first one on the expansion joint systems is really targeted for those bridges that mainly contain steel components below the deck that may be vulnerable to corrosion, whether it's steel superstructure or bearing components. So it's really intended to minimize the occurrence of leakage in our deck joint systems as much as possible. Whereas the second one on the deck joints has a little bit wider tolerances, and it's applicable to all bridges, whether it's concrete, steel, or any other bridge type. And it's really intended to discourage a larger breakdown in our joint system. So we're really trying to stave off those scenarios that might contribute to erosion around our substructure components or debris collection around our bearings. The one on the steel protective coatings is focused on functionality more than anything else. It's really intended to minimize the occurrence of where our underlying steel is exposed and vulnerable to corrosion. So again, all of these are using that same two-part scenario to ensure a certain level of functionality in those select components and ensure value for us over the long term. So one thing we realized is that as we reviewed these types of items, we figured that we needed some tools to gauge the potential for them to provide value for us over the long term. And so what we did is we simply developed a spreadsheet that allows us to report on these types of metrics. And it contains a querying mechanism that allows us to interact with our larger statewide bridge inspection database, BRM. And simply allows us to be able to bring in only the information on select populations of bridges however we choose. In this case, we're reflecting whole districts, about 700 bridges. But we can identify a bridge group, say if we have a group tied to a performance-based contract or a maintenance yard designation, however we define it, big or small, and simply just set up to report on these types of metrics. What you're looking at here is the deck summary. So we're reflecting on each of those material types. And under each of those material categories, we've got just a data table reflective of those elements that are comprised of that material type that are part of our deck systems. So the left part of the data table reports on our efforts to ensure that we have a certain amount of good quantity, generally condition states 1 and 2, whereas the right side of the data table reports on our efforts to minimize the occurrence of those undesirable defect scenarios. One thing we realized is when we began plugging in bridge group after bridge group into this tool, we understood that the information could vary a bit on this type of reporting due to a lot of different influencing factors. So one thing we did is we developed an overall summary that kind of allows us to view the information on these types of items in context with those other influencing factors, whether it be age, detailing, types of bridges, things of that nature. So again, all information is reported on individual population of bridge, however big or small. The top portion here is just reflective of our general condition ratings, which is based on those minimum NBI components. And then in Florida, we've used a 4 classification scale for a long time, either excellent, good, fair, poor. And we're also reflecting the newer FHWA criteria, which just has 3 categories, good, fair, poor, which is dependent upon those percentages by deck area. So in the middle here, we're reflecting on those element level performance measures that are in support of our bridge preservation objectives. Just listing those element level performance measures that we spoke of, 5 on the deck, the 2 on expansion joints, 1 on the steel coatings, and we've left room for others as well. And really, we wanted to set up just a framework that allows us to view the change in this type of information over time on these metrics. So for example, if we had a 10-year performance-based contract, we could record the baseline data in the beginning column at the start of the contract and provide interim reporting, probably on a 2-year basis, as we progress through the term of the contract to make sure we were staying within our performance expectations. Down here on the bottom, we're reflecting some various bits of miscellaneous information, those other influencing factors. We're listing decade of construction, which gives us a sense of detailing, general condition, bridge types, our material distribution, just give us a sense of what potential challenges may lie within this particular population of bridges. Down here on the right, you see performance exemptions. Simply just a tool that we developed that allows us to better coordinate with ongoing work on our bridges. And it's listed as an exemption in respect that allows us to omit either just select bridges or even just portions of bridges from the element level reporting that's in support of our bridge preservation strategies. For example, if we have a lot of bridges coming out of service, we could omit the reporting on those bridges. In a sense, when we turn off the reporting, that's the driver of that type of work activity, because we really want to make sure that our valuable bridge preservation resources are going to those bridges that need it most, those bridges that will be in service for a while. So in summary, we're currently looking at condition-based, outcome-driven performance measures that we believe will provide value in the overall life of the bridge related to our deck systems, our expansion joints, our steel coatings. Are there others? We've been talking a lot about the movable bridges lately. We'd really like to wait until we get to the end of our first bridge inspection cycle. The first 2 years, we'll be there probably in January of next year before we finalize those performance thresholds. We believe performance measures, if appropriately established, will serve to incentivize preservation performance in all of our processes, whether there's a performance-based contract or not, and provide an opportunity for our best and brightest contractors to compete for our business on the basis of bridge preservation, which is really a win-win situation for all.
You mentioned a couple of times you want to maximize the condition states 1 and 2, and also have another focus on minimizing the undesirable defects. Why are those two separate? If you focus on minimizing, won't the maximization automatically happen?
Remember when I said the devil's in the details? As we look at the various criteria that's contained with each of those condition states, let's just say some condition states are worse than others, or some defect scenarios are worse than others within the same condition state. So it's not always uniform. So we really want to take steps to make sure that, like, as I mentioned, that we had an outcome-driven process which acknowledged the benefits of repair activity and addressing those deficiencies that we could pay long-term dividends for us, and really taking steps to avoid those scenarios that promote elevated rates of deterioration. And that's why I kind of use the exposed reinforcement as an example for.
The unit of measure for the elements influences how some of these performance measures actually function. What insight have you got on, since you've been doing this for a little bit here, on the influence of the unit of measures and what changes should be considered by AASHTO for unit of measure changes for some of these elements?
That's a great question. First, let me say I give a lot of credit for those that had a hand in development of the latest version of the standards, because we've taken great steps to develop more tools that can be quantifiable for us. For example, we report on condition by square foot on our deck systems now. We report on units or elements of our coating systems on a square foot basis. It gives us great opportunity to observe rates of deterioration in our components and observe when function may be failing on a broader scale. And these protective systems are the types of elements that are prone to aggressive maintenance. And really that's what we're trying to do here, is implement strategies for aggressive maintenance of those systems that are more protective in nature. If we continually do this over time, we know that's going to pay significant benefits for us over the long term. So as far as granted, it's a little bit more work on the front end to report on condition for these types of items, but it pays significant dividends in the respect of being able to use the data to drive performance.
Well, one of the things reason why I was asking is because there's a disconnect, like for protective system for steel versus how steel is actually measured for the element itself, and that's the reason why I was asking that question. If there's you're having problems trying to get that connection back to some of these that are eaches and linears versus squares and those type of things.
You know, it's interesting because we're always involved with ensuring that our information is being recorded in strict accordance with the criteria. And you're right, steel beams, we quantify on a linear footage basis, but the coating system is on a square footage basis. So we disconnect hopefully they correlate, because if we've got a breakdown in a protective system, we know that it will eventually relate to deterioration within our base elements. But yeah, we have to almost look at each of those components individually and have targeted programs to ensure functionality and different methods for each of those. But no, it's a good question.
Sir, is your ultimate goal is to put like a preservation type of contract, let it and the selected bidder basically has like a multi-term contract, and you're going to say you're going to preserve and maintain these bridges at a certain rate, item rate, and in condition with the condition state?
What we do is we have a long history here in Florida of using performance-based contracts, where some of those shorter-term asset maintenance contracts, they're scoped to provide maintenance and repair activities. So they assume the risk. If the need shows up within the term of their 10-year contract, 7 to 10-year contract, they're going to be responding to those needs. And we have what we hope to do is have good performance thresholds and understanding. Typically, our performance contracts are structured to include disincentives. So if they don't meet those thresholds, those disincentives would kick in. And we think that there may even be opportunity for the potential for incentives related to this type of work as well. But we're still kind of waiting to see how that plays out in the contract realm.
Yeah, and your preservation contracts is basically you're handing them this set of bridges over to a contractor for a certain amount of time. We're going to inspect them. Anything comes up, you're fixing it.
Absolutely. They own responsibility for a certain class of work, and so if the need comes up that qualifies for that class of work within the term of their contract, they need to respond to that.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.